What up, what up? I'm the math teacher Goat, and today we are doing a full lesson on AP Precalculus 2.10, inverses of exponential functions. We kind of already know what an inverse of an exponential function is if you watched my last video, but we're going to do a little more involved. Please download the notes in the description. There's a copy in the description. Like and subscribe, leave 50 comments, and just telling me how much you love me. Please. Please. I need that. What do the kids call it? Clout. Clout. If that's still even a thing in 2025. Rewrite each in the other form. Well, let's remember that to convert a log to an exponential or an exponential to a log, you have log base b of y equals x, and that can be written as b to the x equals y. And vice versa. So this is logarithmic form. You would label u b, you would label u y, you would label u x, and so we would write that out as b to the x equals y. 7 to the x equals 49. We don't have to solve, but if we did, the answer would be 2. 6 to the x equals 36. Well, that's in exponential form already, so you're my b, x is my x, 36 is my y, so log base b of y equals x, log base 6 of 36 equals x. You're in logarithmic form, so you're my b, you're my y, you're my x, so b to the x equals y is going to be 5 to the negative third equals 1 over 125, like so. 10 to the x equals 0.0001, or 001, and you're b, you're my x, you're my y, so log base 10 of y equals x. And we already know that log base 10 just can be written like that. So let's just be proper, should we, please? Now let's remember the basic steps to finding an inverse. Okay, f of x equals 4x minus 5. Let's replace f of x with y. So y equals 4x minus 5. Step 1 is to swap the x and the y. So x equals 4y minus 5. We're going to solve for the new y. So let's add 5. Let's add 5, cross u out. X plus 5 doesn't simplify, so x plus 5 equals 4y. Let's divide everything by 4. Divide by 4. And 4 plus, I'm sorry, not 4. X plus 5. I'm so sorry, guys, I'm sorry. When I first said it, I sounded very apologetic, very sincere. X plus 5 over 4 is equal to y, so we'll swing it over here. But you know what? I can't leave it like that. Y is f, so f inverse is equal to x plus 5 over 4. So that's the basics of finding an inverse. Of course, we're going to apply that to these things. Exponential functions and logarithmic functions are inverses of each other. Remember? Because they undo each other's operations. An exponential function has the form y equals b to the x. Okay, we put b to the x equals y, no big deal. Where b is a positive base and x is the exponent. A logarithmic function is written as y equals log base b of x. So we are now, okay, so what we're doing now is instead of just focusing on the forms that we were given, we're now making them things that we can solve. Okay, so this is an exponential function, and we're going to write it out like that. So that's why it's kind of written, and that's why for here, if you're like, wait a minute, I thought you said log base b of y equals x. That's correct, but when we graph it, we are making x our input. So we're not thinking about the rule anymore. We are now talking about how are you going to graph these guys. Okay, so exponential form, is f of x equals 2 to the x. So let's kind of do what we did here. This is exponential form. Let's plug in our numbers, -1, 0, 1, 2, 3. So 2 to the -1 is 1 over 2, right? 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. And what we get here are the points 1, 1/2. And I know you see it down here. I'm just proving a point. 0, 1, 1, 2, 2, 4, 3, 8. And as you notice, the y values, the f of x values, double every time the x values go up by 1. Now, if a log is the inverse of an exponential, if you're getting ready to flip out about doing all of this math, don't. Okay, if you're -1 1/2, then ain't you a half -1 because you just flip-flop the x and the y. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. And 3, 8 becomes 8, 3. And what you'll notice for the logarithmic functions is as the f of x values go up by 1, the x values double. Okay, so that's something that we will deal with very, very, very soon. I don't know if I want to tell you now. I might as well just tell you now. Like, you're going to be given problems probably, maybe not in this section, but maybe in the next, where it gives you a table of values and you're going to be asked, is this exponential or logarithmic? You'll know it's exponential if the f of x values are multiplied by the same number every time, as long as the x values go up by the same number every time. For logarithmic, it's the x values that double or triple or go by halves as the f of x values go up by 1 or by 2 or whatever. Okay, now we're dealing with positive bases only, otherwise you can't do these. So when I want to look at the graphs of these, okay, exponential functions, for the most part, are going to look like this when graphed. And we saw that on the other side. Basically, the other half of concave up. Okay, as you move along, it explodes moving upward. Now, the inverse of that, let's try to remember what inverses look like. Okay, inverses say that if I have a picture that looks like this, okay, it's going to be a mirror reflection of the y equals x axis, which means you are going to look like you. So you are going to look like you. That's what a logarithmic function looks like. What's the big idea? That's what your grandfather probably told you when you were little and running around the backyard. The graphs are a reflection in the function y equals x. We know that. The domain of the exponential function is the range of the logarithmic function. That makes sense because they're inverses. And the range of the exponential function is the domain of the logarithmic functions because they're inverses. The operations will undo each other like multiplication or division because they're inverses. And because they're inverses, f of g of x is the same as g of f of x, which must equal f or regular x. Okay? Now, we're not going to necessarily talk about some of the main rules, not yet. But, you know, that will really come into play later on. Okay? Oh, crap. I knew I was going to say this. All right, no big deal. All right, describe the function f of x as an exponent or logarithm and then find its inverse. So I'm going to go back to what I said before and fill in these blanks. With exponential functions, the f of x values increase exponentially. With logarithmic functions, the x values increase exponentially. So when I look at this, the x values go up normally. The f of x values triple. So you are exponential. G is going to be the inverse. So all we have to do to fill in the inverse table is flip-flop these. 1/3, -1, 1, 0, 3, 1, 9, 2, 27, 3. And since this is the log, as the g of x values go up by 1, the x values multiply by 3, which means increase exponentially. So in this box, in this table, the x values multiply by 4, and the f of x values go up by 1, except for this last one, which has to be strange or weird for some reason. That's not the end of the world. I know if I needed to, I can sneak in a 32 and a 3 here. But you're going to be logarithmic, which means you're going to be exponential. And so we do the old flippity-floppy. There you have it. Okay? All right. I'm in my classroom, so if you see people acting crazy in the hallways, or if you hear people being crazy in the hallways, it's because they're being crazy in the hallways. All right, now the main rules here are written on the right, and I'm going to use the left side over here to demonstrate that. Okay, so I have log base b of base b to the k. And all of a sudden you're left with k. That shows me that the log base b of a b cancels itself out, and whatever is left in there just drops down for your exponent. Okay, whatever your exponent rather is, just drops down. So something like that could be like log base 6 of 6 to the 7, because that's popular nowadays. The log base 6 of 6 cancel each other out, dropping down to 7. Now, what would that mean here? Like, why would that imply anything? Well, later you're going to learn how to deal with ugly logarithmic functions. So what if I gave you something like, I don't know, 6... Oh, better yet, you know how to do log base 10 in your calculator. Okay, the log button in your calculator is the same as log base 10. So what if I asked you to find out what log, or what 10 to the x equals 63.4 was? What if I gave you something like that, where you're going to look at that and be like, I don't know, I have no clue. Well, what we could do is we can write this out a little bit nicer. 10 to the x equals 63.4. What we can do is say log base 10 of both sides. Now they cancel each other out. So x is going to equal log base 10, which could be written as just log of 63.4, and I can type that in my calculator. So when you have the log base b of a base, same base to the whatever, drop it down. Now similarly over here, and I really didn't do a good job leaving myself some space, so let me try to leave myself some space, is something like this would be for like if I have 10 to the log base 10 of x. The log base 10 and the 10 cancel each other out, leaving you with just an x. So a way that I could use that, okay, is what if I'm given, we'll stick with log, we'll stick with, no, I don't have to. What if I give you something like log base 3 of x equals -2? And I need to solve for x. Well, what you could do is use your base as a base. So make your 3 your base, and make your 3 your base, and now 3 log base 3 cancel each other out. And you're left with x equals 3 to the -2, which is 1/9. Now, if you're looking at something like that, though, if you're looking at what I originally had there in black, so for an example like this, and you're thinking, why can't I just write that out using the old rule that I did? Because they get more complicated than this. So we're going to want to think these rules of how we could solve using these steps that we just learned. So for example, x equals log base 5 of y. How can I write that out? Well, I have a base of 5, so why don't you make your base 5 and take the 5 to the of both sides? Okay, so base 5, both sides. Base 5, both sides. That gives me 5 to the x, and 5 log base 5 cancels out, equaling y. So y equals 5 to the x if I write it out the way God intended it. 5 to the y equals x. Well, that is a base 5, so why don't we log base 5 both sides? Log, I can't squeeze that in, base 5 both sides. The log base 5 of 5 cancels out, dropping down the y, and that equals log base 5 of x. This is gross. X equals log base 5 of log base 3 of y. Well, I don't care about the insides first. Let's deal with the outside. If I have a log base 5 that has on the outside I have to get rid of, why don't we base 5 both sides? So now I have 5 to the x equals 5 log base 5 cancels each other out, leaving you with log base 3 of y. Oh, but we're not done yet. Why don't we base 3 both sides? So base 3 both sides, so that cancels out, and you're left with y equals, this is weird, 3 to the 5 to the x. I don't have enough space to flippy floppy, so I'm going to leave it like that. 3 to the 5 to the x. Strange! Now determine if f of x and g of x are inverses. So this is going to take me a minute or two. And if you remember how to find out if something is an inverse, f of g of x has to equal g of f of x, and they both have to be x. So if I do f of g of x and get x, I keep going. Then I do g of f of x and get x, then we're good. If I do f of g of x and get 12, well, then I'm done and I can't do any more. So f of g of x is going to be me writing out 2 times log base 2 of 2 to the 2x. Ugh. Okay, write out your log, leave a parentheses there, and plug in your g into that x. Okay, log base 2 of 2 cancels out. So you drop down the 2x, and that 2 is just living there. 2 times 2x is 4x. So f of g of x is supposed to be x. It came out as 4x, so the answer is no, these are not inverses. Okay, let's do it again. F of g of x means I write out f and leave a big parentheses where every x is, so 0.25 parentheses, and in the parentheses I have 4 log x. A quarter of 4 is 1. So this is just log of x. Isn't that just log base 10 of x? Ooh. And you know what? 10 to the log base 10 cancels out, leaving you with x. So far, we're in great shape. Now let's do the other version. G of f of x. Write out all of g, 4 log, leave a big parentheses where the x is, and inside the parentheses put in f of x. So 10 to the 0.25x. Log is the same as log base 10. So these guys cancel each other out. So you're left with 4 that's still living on the outside. Drop down the 0.25x. 4 times a quarter x just cancels each other out, and you're left with x. They both equal x. So are they inverses? Yes. Let's do it again. F of g of x is going to have me write out f, leave a parentheses where the x is, and replace that parentheses with 8 log base 5 of x. These guys cancel out, leaving me with 5 to the log base 5 of x. 5 to the log base 5 cancel each other out, dropping down the x. So far, we're in great shape. G of f of x has me starting out by writing out g, 8 log base 5 of big parentheses, 5 to the x over 8. Log base 5 of 5 cancel each other out. Drop down the exponent to 8 times x over 8. The 8's cancel out, leaving me with x, so these guys are inverses as well. Now I'm going to find the inverse. Using the old-fashioned way, even though I don't want to. That's all right. I like it. I'm going to do it. It's good stuff. Set u equal to y. Y equals, what is that, 4 to the 5x. Swap the x and the y. So x is going to equal 4 to the... You have everything? No help?
I don't know where Zoe is, but I think she should be coming. I think I have everything. Yeah.
All right. Make me money.
Yes, sir.
Thank you, Nora. It's an honor, as always. Just shut the door on your way out. Oh man, it never gets old. Woo! Forgot that was unpaused. All right, my poor eyes. Find the inverse of the given function. Let's do this the old-fashioned way and not knowing some of these. Well, we will use some of the shortcuts. But I'm not just going to say, like, why don't we just set that equal to y and do what we did at the beginning? No. No, we're going to do this the old-fashioned way. I'm going to call u y to make life easier. Y equals 4 to the 5x power. I'm going to swap the x and the y, so x equals 4 to the y, or 5y power, and I need to get y all by itself. So thing number one that we have to do is I have to eliminate that 4 for a base. So how do I eliminate a 4 for a base? We log 4 both sides. So we're going to log base 4 both sides. Log base 4 both sides. That gets me log base 4 of x equals, you cancel out, 5y. Now I'm going to divide both sides by 5. I'm going to divide both sides by 5, cross you out. And I'm going to write it out like this because it's a little more proper. You usually don't want to put over 5 for logs, although it's not the end of the world. I'm just going to write out 1/5. So y equals 1/5 log base 4 of x. And I'm going to put it all together by making that y f h. It's 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 h. H inverse of x equals 1/5 log base 4 of x. Let's do it again. Y equals 5 log base 2 of x. Swap the x and the y. X equals 5 log base 2 of y. Before we can do anything, let's divide both sides by 5, just joking. Divide both sides by 5. X over 5 equals, let's leave some space, a teensy bit of space for log base 2 of y. I have to get rid of that base 2 there. So I'm going to base 2 both sides, and that'll cancel that out. So now I have 2 to the x over 5 equals y. I'm going to write it out as an m, and inverse of x equals 2 to the x over 5. Okay. Which of the following represents a possible function that is the inverse of this exponential function? That's exponential, which means its inverse has got to be logarithmic. Now, if I were to try to draw out this guy, you'll notice that this is exponential decay. Okay, so it's going to start up here and really hit that and then flatten out at the x-axis. So the inverse of that would be a graph that is a mirror image over the y equals x axis. Now, I'm awful at graphing these, but what that's going to look like is you're going to come back up here and hug the x axis, and you're going to come down here and cross over and just kind of like go down a little bit. So C looks like it could be our guy. Now, I'm not sure if we're supposed to do all of these. You were the original, so it's not you. Now, this is exponential, which means if I want to find the inverse, a really quick inverse, y equals 0.25 to the x, flip-flop the x and the y, so x equals 0.25 to the y. I'm going to log base, so it's going to be log. So it's going to be log. And if the base is going to be, I'm not even going to go any further. It's got to be these. It's got to be C. Although C looks like it's a log. Oh, you take a quarter of it. All right. So it could be B. Hold on. It could be B. And you know what? Ignore this. I don't even want to do it anymore. If I want to make a quick chart for this using these numbers, in fact, I'll just do 0, 1, and 2. If I plug in 0, I get 1. If I plug in 1, I get 0.25. And if I plug in 2, a quarter squared is 1/4 times a quarter, which is 1/16. Now, this is the original, which would mean that the inverse is flopped. So you're going to be 1, 0. You're going to be a quarter 1, and you're going to be 1/16 2. So that works. Two of them do work. Oh, that was a close one. That was a close one. All right, last one. The function g of x is defined by g of x equals log base 5 of log base 4 of x. Which of the following is an expression for its inverse? We did one like this. So let's just, trade away the g of x with the y. So log base 5 of log base 4 of x. With a bigger looking parentheses than that. Swap the x and the y. So x equals log base 5 of log base 4 of y. And so my job is to unlock that y from inside a log base 4 and a log base 5. So let's get rid of the exteriors first. How do I get rid of a log base 5? Well, let's base 5 both sides, so that'll cross u out. So now I have 5 to the x equals log base 4 of y. How do I get rid of log base 4? Same idea. Base 4 both sides. So that crosses u out. Now I have 4 to the 5 to the x equals y. Flip it around. Call it F inverse? G inverse. I always do that. I never look first. G inverse. G inverse. 50 cents. That equals 4 to the 5 to the x. Like that. Which looks like B. All right. So as always, like and subscribe. Run to my YouTube and watch videos on, what was this, 2.10? Is that what I'm looking at? I think it's 2.10. I'm looking at, yep, 2.10. So go type out AP Precalculus 2.10 in my YouTube, and you'll get to see some of my random AP Precalc videos that are just like, more problems that you could possibly see on like a test or an AP exam or something like that. Just different ways for you to understand things a little bit more. As usual, though, thanks for watching. As usual, I think I said that already. And as usual, like and subscribe. And as usual, watch my videos. And as usual, have a wonderful day. And as usual, bye.